Geometric sequences. A geometric sequence results when you multiply a number by another number called the ratio, and then multiply the answer by the ratio again, and then keep multiplying your answers by the same ratio. That is called a geometric sequence. The very first term is called a sub 1. The ratio we will call b, although many places call it r. Either one is correct. A sub n means the nth term in the sequence, so a sub 6 would be the sixth term. We are going to learn two formulas for finding the nth term of a sequence. The first is the explicit formula. In this one, it's a sub n equals the first term times the ratio to the power of 1 less than n. The second formula is the recursive formula. This one is a sub n equals the previous term times the ratio. To understand what is meant by this, let's look at an example. This is a geometric sequence. The first term is 4. Each term is found by multiplying the previous term by 3. The ratio is 3. The recursive formula is just the mathematical language for saying that to find any term, you must multiply the previous term by 3. To find the fifth term, we would multiply 108 by 3 to get 324. To use the recursive formula, you always need to know the previous term. The explicit formula allows you to find any term as long as you know the first term and the ratio. It is a sub n equals the first term, which is 4, times the ratio, which is 3, to the power of 1 less than n. To find the fifth term, we write a sub 5 equals 4 times 3 to the fourth, because 4 is 1 less than 5. This equals 4 times 81, which equals 324. The same answer we got by the other method. Now pause the video and try the next example yourself. Now that you have tried it, check your work. The first term in this sequence is 3. Now find the ratio. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. The ratio is 2. Thus, the recursive formula, to find any term, we multiply the previous term times 2. To write the explicit formula, write a sub n equals 3 times 2 to the n minus 1. Thus, to find the seventh term, we would write a sub 7 equals 3 times 2 to the sixth, 1 less than 7. 3 times 64 equals 192. This method is much better and quicker than the recursive method, which would require us to multiply 24 times 2 for 48, 48 times 2 for 96, and 96 times 2 to get the seventh term, 192. Preferred method is the explicit formula. Sometimes the ratio can be a fraction. In this case, the first term is 2. 2 multiplied by 1/3 makes 2/3. 2/3 multiplied by 1/3 makes 2/9, and multiply by 1/3 again for 2/27, and then 2/81. The ratio is 1/3. Thus, the recursive formula is a sub n equals the previous term times 1/3. The explicit formula would be a sub n equals 2 times 1/3 to 1 less than the power of n. To find the 10th term, then, you would write a sub 10 equals 2 times 1/3 to the power of 9. Use PEMDAS when figuring this out. A sub 10 equals 2 times 1 to the 9th over 3 to the 9th. Putting this in the calculator, we get 19,683. Multiply the numerator by 2 for 2 over 19,683. We would not want to use the recursive formula to multiply by 1/3 so many times. Explicit formula is definitely preferred. When we start with the explicit formula, it is very easy to find the first term. This one is 7. Also the ratio. The ratio has a power with it, and it is 2. The first 5 terms of this sequence are 7. 7 times 2 is 14, times 2 is 28, times 2 is 56, times 2 is 112. To write the recursive formula, we just need a sub n equals the previous term times 2. To find the 9th term using the explicit formula, we would write a sub 9 equals 7 times 2 to the 8th power. This gives us 7 times 256, which equals 1,792. Now pause the video and try the next one yourself. Now that you have tried it, check your work. First, you need to identify the first term. That is the number that is not touching the exponent. In this case, 3. Now you need to find the ratio. The ratio is the number touching the exponent, or 2/5. The first term is 3. Multiply the first term times 2/5, or 3 times 2 on the numerator for 6, and the denominator is 5. Multiply 6/5 by 2/5. 6 times 2 is 12. 5 times 5 is 25. Multiply again. 12 times 2 is 24. 25 times 5 is 125. Multiply again. 48 over 625. The recursive formula just means each term that we look for equals the previous term multiplied by 2/5. To find the 9th term, however, we will want to use the explicit formula. So a sub 9 equals 3 times 2/5 to the 8th power. Remember to do the exponent first. So we write 3 times 2 to the 8th over 5 to the 8th. Now break out the calculator. 3 times 256 over 390,625. Now we multiply the numerator by 3 for 768 over 390,625. This would have been very difficult to get by using the recursive formula. This is why we prefer the explicit formula. In the next example, it looks like the first term is missing. We have a number touching the exponent, that's the ratio, but what about the first term? Well, rewrite the formula as 1 times 5 to the n minus 1. Now we have it. The ratio is 5, the first term is 1. The terms are 1, 5, 25, 125, and 625. To write the recursive formula, it's the term we're looking for equals the previous term times 5. To find the 8th term, use the explicit formula. A sub 8 equals 1 times 5 to the 7th power. Break out the calculator. 5 to the 7th equals 78,125. When we begin with the recursive formula, we have to be given the first term also, because the formula only has the ratio. We get the ratio from the formula, which is 4. Start with 2. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. 128 times 4 is 512. To write the explicit formula from this information, I would write a sub n equals the first term, which is 2, times the ratio 4 to the n minus 1. To get the 9th term, I would use the explicit formula. A sub 9 equals 2 times 4 to the 8th. Do the exponent first. For 2 times 65,536. Now multiply by 2 for 131,072. This is the 9th term. Now pause the video and try the last example yourself. Now that you have tried it, check your work. The first term is 2. The ratio is 1/4. So we begin with 2. 2 times 1/4 is 2/4, which can be simplified into 1/2. 1/2 times 1/4 is 1/8. 1/8 times 1/4 is 1 over 32. 1 over 32 times 1/4 is 1 over 128. The explicit formula for this would be a sub n times the first term, which is 2, times 1/4 to the power of n minus 1. Using the explicit formula, we can find the ninth term. A sub 9 equals 2 times 1/4 to the 8th power. This equals 2 times 1 to the 8th over 4 to the 8th. Multiply the numerator by 2 and we get 2 over 65,536. This can be simplified by dividing the numerator and the denominator by 2. Thus the final answer is 1 over 32,768. Please use these notes as you complete your homework. Thank you.